So the first question here, we're going to look at what it says in the problem. It gives us a visual, which is nice. It says in the figure, GH and GI are tangent. So I'm going to identify those. GI and GH are both tangent. And one of the theorems we learned is that when you have two tangent lines coming from the same external point, then they are the same length. So we can label that. So these are tangent. And then it says that, okay, so another theorem before we go into more information, another theorem that we learned is that when you have a tangent and a radius right here, it makes a 90-degree angle. So that will be helpful as well. And it says that OH is 3.2. It labels that, but I'm going to just make it a little bit more clear. That's 3.2. And then GI is 6 right here. And then because these two are the same length, this would be 6 as well. And then it's asking for you to find the length of OG. Length of OG is this segment right here. So we'll make that our X. Okay, so how would we find that? Well, based on what I have, I see a right triangle, and I can use Pythagorean theorem to find the length of that segment. So that's what we're going to do. We're going to use Pythagorean theorem. A squared plus B squared equals C squared, and then use these two legs and plug it in. And then solving this, 6 squared would be 36. 3.2 squared is 10.24. 3.2 squared is 10.24. Oh, yeah, solving. And then add these two together, we get 46.24 equals C squared. Then take square root of both sides, and C equals 6.8. So this length right here, 6.8. OG is 6.8. Also another way they might ask it, like same situation, same theorems and everything, but sometimes they'll give you the hypotenuse and you have to solve for one of the legs. So sometimes you're solving for like A or B instead of C. But at this point you should be able to do it either way. Next one. Ready? Okay, so we're gonna move over here. So for this one, and it's important to label the figures, it makes it so much easier. I realize you're doing this on a computer, which on the EOC you'll also be doing it on a computer. So draw this on a piece of paper and like just label it on the piece of paper. So arc AB is 50 degrees. Silas, can you put the tablet away, please? CD is at 74 degrees. And then it says find the measure of CED. So I trace CED, okay, it's talking about this angle right here. Okay, so to find that angle, we just need to take the average of these two arcs, and that'll be this angle. So we add these two arcs together, 50 plus 74, and we'll divide by 2, and that'll give us the middle number, the average. So 124 divided by 2 is 62, and that's our answer. The other thing that they might ask for, so either way you're going to find the average of these two arcs. The other thing that they might ask for is this angle, and this angle would be supplementary to this one, so you could do 180 minus this number. Just FYI. But yeah, as you have questions, just let me know. And then for this one, first things first, let's label what they gave us so we can figure out what we need to solve for. So it says PUR is 64 degrees. And measure of arc ST, UR is the 64. Arc ST is 44 degrees here. And it wants to know the measure of PR, arc PR right here. So this would be X. Okay, so we're going to have to use the equation big arc minus small arc. Divide by 2 equals this angle. So the equation is big arc minus small arc divided by 2 equals the measure of the angle. And that isn't on a reference sheet or anything, you have to know that equation. Okay, so then plugging these numbers into the equation, we have X, which is PR, minus the small arc, which is 44, over 2 equals 64 degrees. Big arc minus small arc divided by 2 equals 64. Then from here, we're going to solve for x. So first step would be multiply both sides by 2. This cancels. X minus 44 equals 128. Add 44 to both sides. And x equals 172 degrees. So that would be what goes in the box here. X equals 172 degrees. Of course, make sure it's logical too. Of course, it shouldn't be like bigger than 360. 360 would be all the way around. It should be bigger than the small arc, of course, so that seems logical. Okay, then over here we're going to skip the honors one, so you can kind of like just cross them out, and then go down here. Okay, so for this theorem, it is this segment EG squared equals CE times the length of the whole thing, so DE. So we are going to use this equation. Let's see. Let's plug in the numbers and label it. It says ED is 31.5 and EG is 21, and then find CD. So we're finding this right here. But for our equation, we actually need CE. So what CE would be, since the whole thing is 31.5 and this part is just x, then CE would be 31.5 minus x. Okay, so then now that we have everything labeled, we can plug it into our equation. So it'd be 21 squared equals CE is 31.5 minus x, and then DE, the whole thing, is 31.5. So the calculations on this one are a little weird, but the concept's pretty simple. It's just they give us kind of weird numbers. Okay, so then solving this, 21 squared is 441. We have this here. To multiply this, we're just going to distribute this term to both of these. So 31.5 times 31.5 is 992.25. And then x times this minus 31.5x. Okay, and then from here, just continuing to solve for x, I'm going to subtract 992.25 from both sides. That comes out to negative 551.25 equals negative 31.5x. Divide by this to get x by itself. And x equals 17.5. So the length of CD equals 17.5. Okay. The next one here, this one's actually easier than the one previous. The equation for this would be like this short segment on the exterior times the whole thing. This segment here times the whole thing. So they gave us the numbers. UX is 22.5. UY, so the whole thing is 60. UZ is 30. And then UW, the whole thing, is what we're trying to find, so that's x. So we will do 22.5 times 60. equals 30 times the whole length, which is x. And then we can solve for x. So 1350. So this times 60 is 1350. 30 times x is 30x. Divide both sides by 30. And x equals 45. So w equals 45. Okay, so the rest of the problems are dealing with the equation of a circle, so we're kind of transitioning over there. So it's the same questions we practiced yesterday, so it should start feeling easy again, which is nice. Okay, so over here, starting with this one, and it starts easy and it just builds a little bit more challenging each time. It says the equation of a circle is given, identify the radius center, and then graph the circle. So the equation of a circle is x minus h squared plus y minus k squared equals the radius squared, and hk is the center of the circle. So these two numbers are the center, like the coordinates of the center, and then the subtraction symbols with the equation, it's not with the number. Okay, so based on that, in this equation, we have 1 here and 2. So the center is at +1, +2, and then the radius, you just take the square root of this number 16 to get 4. So radius is 4, the center is at 1, 2. And then once you have those numbers, you have partial credit, of course, and then you get full credit by also graphing it correctly. So you do 1, 2 to get the center, and then just mark 1, 2, 3, 4 units in each direction. And circle, okay. Okay. Next question, write an equation of a circle whose center is at 2, 6 and diameter of 10. So the center, we can just plug that into the equation. We also need radius. They gave us diameter, so we need to divide that by 2 to get radius. So the radius would be 5. And now we can plug the numbers into the equation. So it'd be x minus your x coordinate here plus y minus your y coordinate squared equals the radius squared. We don't leave it like this though. We would actually solve that out to be 25. So x minus 2 squared plus y minus 6 squared equals 25.
Wait, when the numbers are negative though, you do x plus 2, right? If
Yes.
the 2 would be negative.
Mm-hmm. Yeah. Okay, the next one, again, is building a little bit in complexity each time. Find the equation of a circle, so we're finding this equation. It gives us the center, so we're just going to plug those in with the x and the y, which is no problem. But it doesn't give us the radius this time. It just says that it passes, like the center of the circle is at -5, 1, and then the circle passes through this point. Well, the distance between the center and this point would actually be the radius of the circle. So to find the radius, we have to find the distance between the 2 points, find distance. So to find the distance, we're going to use the distance formula, which is on the reference sheet. It's x2 minus x1 squared plus y2 minus y1 squared. So this would be x1, y1, x2, y2. Okay, so we're going to plug these numbers in here. -1 minus -5 squared plus 6 minus 1 squared. Okay, so add the opposite here, we'll get 4 squared plus 5 squared. So I get 16 plus 25, which equals square root of 41, and that's the radius. And now that I have center and radius, then we can plug it into the equation. So it'd be x minus -5 squared plus, just using this coordinates of the center, y minus 1 squared equals the radius squared. And then simplify this one step further, the double negative will be plus, and then square root of 41 squared is just going to be 41. So it'd be x plus 5 squared, y minus 1 squared equals 41 as a whole number. Okay, the last one is the one with all the steps, but also very common on testing. So first step, it gave us general form, we have to get it into standard form, so that way we can identify the center and the radius and then graph it. So the first step is to group the x's with the x's and the y's with the y's. So x squared plus -6x plus blank plus y squared minus 2y plus blank. And then the -15, we just put it on the other side by adding 15 to both sides, so we equal to positive 15. Okay, then the next step is to take this middle b term, -6, divided by 2, and then square it to get 9. So we took that term, divided it by 2, and then squared it to get positive 9, and that's the number that goes in the blank, and whatever we add on this side of the equation, we also have to add over here. Okay, and we do that same thing with this -2 here. -2 divided by 2 is -1. Square it, and we get positive 1. So we put 1 in blank and add it to the other side as well. Okay, next step is to factor this out. So here in the next here. We need two numbers that multiply to 9, add to -6. So that would be -3 and -3 would multiply to positive 9 and add to -6. And same over here with the y. Two numbers that multiply to 1 and add to -2 would be -1 and -1. And then add these three values up and we get 25 here. Going to simplify it, put it in standard form for the circle. There's standard form of the circle, and then from there we can pull out the center and the radius. So the center would be +3, +1. And then the radius, you just take square root of 25. 25 equals 5. So radius is 5, center is 3, 1. And then the last step is to graph it. So the center at 3, 1, radius 1, 2, 3, 4, 5. I'm just counting 5 units in every direction. So that way I can properly graph it. This will be easier on the computer. And graph your circle. So now your to-do list is leave this test out for me to grade. And then there's a practice test on ALEKs for you to practice these problems on your own to prepare for the test. They're the same questions that you'll see on the test tomorrow, so make sure that you are good and ask questions as you need. Yes, you can. plus 7.